Dear student, today we can discuss few topics on the chapter phase equilibria, and today my topic is two component system. A system, first of all, we discuss what is system, what is component. A system is defined as the part of the universe which is under investigation. Here we can discuss the phase diagram. And what is the component? The smallest number of independent variable of chemical constitute by the mean of which the composition of the phase can be expressed either directly or in the form of chemical equation is known as a component. It means that let us take an example that water is exist in three phases: solid, as well as liquid, as well as gases. If it is solid, it represent in the form of ice, it represent in the form of liquid, and it represent in the form of a gas state. They are all in equilibrium and having three phases: solid, liquid, and gases respectively. But the composition of all the phases is only water. So water is a one component system. So C is equal to 1. We can take also another example, that is sulfur exists in four phases: sulfur rhombic, sulfur monoclinic, sulfur liquid, as well as sulfur vapor. All are in equilibrium. All are in equilibrium. Where rhombic and monoclinic, they are solid in nature, it is liquid by nature, and it is a gaseous by nature. Due to different geometry of sulfur rhombic as well as sulfur rhombic, they are two different phases, but they are exist in a solid mainly and having two phases: sulfur rhombic and sulfur monoclinic. Because phase is a homogeneous, phase is defined as it is homogeneous system as well as physically different, so they have different geometry, so we can consider this two phases, neither one phase. Physical different and mechanically separable, as well as well defined boundary surface or interface is known as a phase. So here the two component system, it means that C बराबर है 2. When the number of component are increased, automatically the phase is decreases, and if it have least value, that is P बराबर है 1. So putting all these value in Gibbs phase rule, F बराबर है C minus P plus 2, where F is the degree of freedom, C is the component, P is the phase, and 2 is a constant quantity. Now what is degree of freedom or variance? It is defined as simply, it is the every system having three variable: temperature, pressure, and concentration of the component. If one value is fixed, automatically all the condition of the system is completely defined, is known as degree of freedom or variance. By putting all these value, P बराबर है 1, C बराबर है 2, इन गिव्स फेस रूल F बराबर है 2 minus 1 plus 2 is equal to 3. So in two component system, degree of freedom is 3. So it is a trivariant in nature. All the factor, temperature as well as pressure as well as concentration of the component in variable condition. But the phase diagram of two component system having three-dimensional structure is plotted, so it is difficult to understand the phase diagram. That is the phase diagram of two component system. Having along x-axis temperature is variable, along y-axis pressure is variable, along this axis composition of the component is a variable. So it is not easy to make three-dimensional structure, so one of the variable should be kept constant, hence the system become condensed, and that system is known as condensed system. Let us take an example of a metal alloy. When metal having varying, we know that metal have very high melting point, and when alloy are made, they are exist in solid liquid equilibria. Hence there is a no vapor pressure existing due to the boiling point of the temperature. We already know the definition of boiling point. It is the temperature at which internal vapor pressure and external vapor pressure are same. When we know that here the melting point of the metal alloy have varying high, so the internal external pressure is not same. So in this we can kept pressure constant, and the pressure term is neglected. We know that the Gibbs phase rule F बराबर है C minus P plus 2, where 2 specify the term temperature as well as pressure. If the pressure is neglected or kept constant, so automatically this phase rule is reduced, and hence another phase rule is introduced, or modified form of phase rule is introduced, and that phase rule is known as reduced phase rule. And here F बराबर है C minus P plus 1. So it is the another phase rule equation mainly used in a two component system to determine the degree of freedom or variance. Now we can also classify the two component system further. The two component system further is classified into three types. First one is your simple equidistant system. Second one is your system with congruent melting point. Third one is system with incongruent melting point. The two component system are classified into three types. That is the types of two component system. And what is the simple equidistant system? A system in which two or more component, a system in which one or two or more component are mixed with each other without chemically reacting with each other, and their certain composition will form a mixture, and that mixture is known as equidistant mixture. The system where equidistant mixture is formed is known as equidistant system, and it is a simple by nature, so it is known as simple equidistant system. Lead silver system is a common example of simple equidistant system. Another classification of two component system is system with congruent melting point. When two or more components are chemically reacted and there is a formation of new form of a component which have its own sharp melting point. The temperature at which compound melt is known as congruent melting point, and it represented maximum phase diagram. Zinc magnesium system is system with congruent melting point. Third types of two component system is system with incongruent melting point. In a system, when the component form a compound which dissociate before its melting point arrives, this temperature is known as incongruent melting point, and the system arised is system with congruent melting point, which is the type of a two component system. Dear students, one more question is asked by the examiner. What is the thaw point? Thaw point, it is the temperature at which where the liquefaction started is known as thaw point. The temperature at which melting is started in a crystal is known as thaw point, and the temperature at which complete crystal is changes into liquid state is known as melting point. So that is our topic for today, the two component system, and it is also known as solid liquid equilibria. Thank you.